looks like one new person here, Pterosaur, and so or Pterosaur. Don't know how to say it exactly, but I wanted to show you. These are the meeting notes that go out every week. See, and so I'll make sure that you get a copy of these. But this goes out weekly, and it talks about what we did and who was here and what we talked about, the PRs that we covered, and the updates and things like that. So just want to let you know that's kind of what we do. And so based on last week, it looks like we had I mean, we all know the things we covered last week. It was pretty heavy week. We merged a lot of PRs. And Marian helped answer this question here. And we covered the issue about the extra VNIs and baby hero tests using TCP, all that stuff. And then this week we were asked if we could add PR 350 into the conversation. So I'll pull that up if we want to do that one first. And oops, it looks like it wants me to do my recovery settings. Just one second. Oh, okay. Yeah. And so I'm presenting 350 right now, which is a protobuf description. And so Zeke, did you or Prince want to take over?
Sure. Thank you.
Okay. Do you want to present or do you want me to stop presenting? How do you want to do this?
I can just share my screen.
Okay, I'll stop then. Thank you.
Yeah, I prepare some slides for it.
Awesome. Thank you. You know, everyone's been kind of wondering who this GitHub handle is, so it's nice to meet you.
Thank you. Okay, can you see my screen?
Yeah, we see it. We see it. Thanks.
Okay, thank you. Let me get started. Let's get started. So first, let me introduce some background. First, here is a tip. The first slide I will introduce the typical SONiC table. In the typical SONiC table, we use REDis to sort each entry and the key corresponds of table name, entry name, and to some entry maybe we have sub entry name. If we have, and the value will be an attribute table, and the attribute name is a fixed constant string, and the attribute value is the clear text for each type. If the IP it is IP string, or if ENI or something, it will be an integer string. So here is an example to VNet table. The lower left picture is the format in REDis DB. And the lower right table shows the memory consumptions of this kind of format. As you can see, the total estimated memory usage is about 65 gigabytes. The entry size of each number is based on the scalability table we in the DASH high-level design doc. Memory consumption is too big to us. As you can see, the issue is too many fixed same consistent string for attributes name and too long clear text, for example, for the IP address and for some numerical value. So here is an example to the DASH VNet table and the detailed content. Do you have any question? If no, I will come to the next. Okay, and right now, let me see the advanced protobuf table. The key is same as the typical design, and but the value we can only has one pair of attribute in the attribute table. So, for example, like this one, obviously, too many same attribute name has been removed, and the type of value, like IP, will be compressed to the binary format. So we pay the directly readabilities, but again, the less resource consumption. As you can see, to the protobuf table, we will only take about 40 gigabytes to the although to the loss of readability, but I believe it is easy to return by advanced CLI if we want to read something from the REDis table. So the next is we can now we have 3 advantages if we convert to the protobuf format. The first and most important is less memory consumption. The memory consumption is degraded from 65 gigabytes to the 41. And the protobuf has a good binary maintainability. It is easy to add new feeds for an entry, and protobuf is bi-direction compatibility, which means in the code level, the new message can be used by the old program, and the new field will be ignored, and the new program can also read the old message, where some new field will be use the default value, and it will also get a clear code in the right now. In the Orch Agent we have too many conversion code to convert the string to the target tab. So in the typical design, we have to do too many conversion from that. And right now is the last slide. I just to tell you how to convert a table from schema to the target protobuf message. And for example, here is the in the first part we will have some predefined tab like IP and IP prefix range and or something. And then I have a table map about how to convert the detailed tab, for example, to the boolean in the protobuf, and to a list. If we want to list a tab, we will use the repeated descriptor to that. And here is an example for the echo rule. To the priority, we use the unsignaled int. To the echo action, maybe we use some enumeration tab. So right now, I have created a PR for the high-level design, and we will create a new SONiC Dash API for protobuf and report for store all protobuf files. But right now I just store them in the my personal report. So that's all about the protobuf part. So any question?
Yeah.
Or I can share this slide.
Hey, this is Vincent. I got a quick question though. This is all REDis database impacting, obviously, but from a SI vendor API level. So first of all, I think the community here for development, at least public, don't really have access to anything REDis, but that's one thing, at least Dash related REDis. But from a SI API standpoint, are there any changes, impact? I'm trying to figure out how this fits into the vendor development, I suppose.
I believe this protobuf description is only to the app.db, not to the site API. But maybe in the future we will also optimize some site tab. Maybe we also use the
that's right.
Thanks.
So at this point, it's mainly targeting the app.db and Orch Agent part, but no changes to the SI and
okay.
Can you describe this a little bit more, Prince? What part is getting affected? What is changing here?
Oh, I think that's what Zah has presented, right? Where previously it looks like, strings and characters in the DB, app.db, but it will be now optimized to use protobuf, where it can have a lot of memory, which we can save. Yeah, it's a kind of the way we save the data. But I
think it might be helpful to have a diagram of this, just because not everyone knows the SONiC architecture thoroughly. I want to make a couple comments. One is what we're doing, I think, is taking individual key values and turning them into a binary blob, which means, it's like all, let's say, chunked together, right, for efficiency. But that means you can't really address through REDis an individual item. It's a blob. That's one comment. And the other comment is, these memory sizes, right? Anyone who knows about the current state of the art in DPUs can look at this and say this exceeds the memory on a typical DPU card, or a darn near large portion of it, which means this is potentially, untenable, even at this level. But I think we need to understand what is the size of the ASIC DB for these configurations, because this is only the tip of the iceberg, right? When this gets turned into ASIC DB entries and they exist simultaneously in REDis, what do we have then? Has anyone looked at that?
I believe it is another topic, because this is about the Dash architecture. Right now, we just to optimize the firstly, we just optimize the FDB, and the FDB will be stored in the host machine, not DPU. Right? This is one question. The FDB is only in the host, stored in the host, and the DPU will use the SWSS because we can DPU we can say it is belong to another machine, and it SWSS can also access the host machines from the TCP or some protocol. But to the ASIC DB will be in the DPU, but the ASIC DB maybe we will remove it. We don't need it. Of course, we can remove the AppDB, but we just to keep the AppDB, because maybe in the future we use some mitigation feature or some, or we want to recover the device from the AppDB. We can leverage the AppDB's data, but the ASIC DB maybe we will remove it. And
can you slow down a little bit? Isn't the DPU running SONiC with the REDis database there as well?
That's what we thought. Yeah.
That's right. I think the point is in different architectures, right? Let's say you have a switch architecture where there is a single AppDB and then distributed ASIC DB. Then that ASIC DB will be on different DPUs, right? So that way the usage or the memory consumption is distributed, whereas AppDB it stays in the host machine, right? So,
but the numbers, if you go back to the numbers, where on the scales, per DPU scales, maybe I didn't actually read the exact numbers there. You know what I mean? It's like,
if
the scale is based on the maximum DPU scale that we have published for Dash, this is our worst case scenario for that DPU, right?
For that DPU, yes, but this is kind of a reference, right? Like you can see how much is the saving by just moving from the regular scheme storage to protobuf, right? It's almost like 20 gig of saving.
I'm not saying otherwise. This is great, but I think the whole idea, the presentation here is about vendors, DPU vendors have to accommodate at least that much to be able for the DPU to support Dash.
Yes.
Well,
that's the key point, right?
This is only the AppDB. It's then translated into ASIC DB, so you've got it twice, right? Some representation of it twice. These entries will be then transformed into ASIC DB entries in the same in-memory process, right?
Yeah, and I think, Chris, that's the point you were making, is that this is...
Yeah, I mean, there's nothing, I'm not at all challenging this optimization. It seems like a good proposal to start with, but if we don't step back and look at the implications of the whole system, we're going to get to the next problem and go, how did we get here, right? We need to look at, the proposition. This is what we expect a poor little DPU to hold in its memory, right? What if it's 138 gigabytes total for the ASIC DB? Has anyone analyzed?
So there is memory consequences should be analyzed for sure, but there is also latency that goes with it.
I think for the ASIC DB part, we have we can always think of like not even write to the ASIC DB, right? You just push the config and then don't write it. So it's part of the syncd implementation on whether to write to ASIC DB or not, because we don't see a reason why we need to save all these things in ASIC DB, unlike the switch. So, but AppDB we want to store. Okay, so we can make such changes to.
Yeah, I mean, I probably will take it in a different, little bit different context, right? The debuggability aspect today, when you have a clear text, it helps in terms of a debuggability. Now, if you have a binary data, I can understand it saves memory, but you will need at least some tools along with it.
Right. I think we'll have to have to know how to interpret these ones, right? Otherwise, it's just some chunk of bytes, right? Yeah.
And to that same point, the ASIC DB, the same point, right? Many times we look at, what applications have programmed to ASIC, and the place to look at is go ASIC DB and check what's the contract between application and ASIC with respect to the data that is provisioned. Now, if we don't store anything in ASIC DB, then the same question will come: what about debuggability? So I think that's
I
just
think
the
that's
gist
the
of it.
compromise I believe we have to make, right? Like sometimes it will be the debuggability, or so if the DB entries are there, it can help in, for sure it can help in debugging and understanding what the entries were programmed. But then the memory usage, if it is going beyond the limits, then there's no way we can scale then, right? Yeah.
Sure. Sure. Yeah, I mean, it's absolutely, it's a balance between those two. But
Right.
my main point was not to lose the debuggability. Maybe if we don't store in ASIC DB, that's a consideration. Then at the same time, we should have a consideration that how can we retrieve the data that
Sure.
can help.
I think will have to decide on what needs to be written and what not, what can be skipped and those things, right? So, yeah. Like for example,
that's a
may be
compromise.
Yeah.
That's a compromise, and the ASIC DB, if we don't store it, it is a function of the DPU vendors to provide the appropriate kind of debug capability there, right? So at the scales that you're talking about, right, Prince, I think you're spot on with that comment. Did I lose you?
Yep.
Driving. So, yes. Yeah, the representing the data in the ASIC DB on the DPUs at the scales would be a challenge. So it is a function of the DPU vendors softwares to essentially provide appropriate debug capability of the entries in their memory tables, I would say, right, as opposed to keeping everything in a version of an ASIC DB at the scales we are talking about. That was my comment.
Yep.
Yeah, and I mean, I'll just take a little bit one step further, is that not the vendor specific debuggability capability, but maybe the standardized one, right? We can skip populating ASIC DB then, but at least define, how vendors can, or how anybody can debug, any DPU system. If you really want to look at what is programming, not the vendor specific debuggability aspect, but the generalized one.
In my opinion, that's hard to achieve, Shitanshu, right? Because nobody will agree on what that standardized mechanisms are going to look like. As long as the appdb config db stuff is represented and you can figure out what's being pushed in, right? You have a layer there, you can at least peek and poke perhaps, and then beyond that it's somewhat kind of specific to the implementations.
Yeah, I mean, maybe, Microsoft or customers really can be a judge of it. There is a vendor side of view and then there is a customer side of view, or somebody who wants to debug, the ASIC DB kind of functionality across different vendors. Are they comfortable to run with vendor specific debuggability aspect or not? So I'll let them comment what makes more sense. But I think my point was mainly started from the AppDB binary data, and just to make sure that we have enough tools for debuggability. And then we just got into ASIC DB discussion because we talked about skipping that as well, and somehow have a way to debug that as well.
So it sounds like we may even on the sorry.
No, go ahead, Vincent.
Just on this, if you go to the binary app database, that's fine. That's obviously smaller, but clearly when you try to dump the keys and verify stuff there, we need to be able to stringify that stuff back to something we understand, we can visually understand, right?
Yes.
Not sure how we do that with the infrastructure.
First, I believe we will tag something to identify which binary we are using, because as I said, we will create a new report for it, and then we will provide a CLI to read it.
So you got to wrap it around the REDis database to do just that.
Yeah. Because right now we have some SONiC DB CLI. We already have that tool. Maybe we can based on that tool to add something in that tool.
Yeah, I guess we wouldn't go to the REDis database directly. We'll just go to the over database. All right, thanks.
I understand that there is some Dash code already in SONiC. Do we have a design of changes that we discussed today other than the protobuf format, like eliminating ASIC DB, running app DB in the host, those kind of things?
No, Reshma, that depends on the platform architecture, right? But today we have developed the code for DPUs, and based on today's discussion, it's mainly on the AppDB to Orch Agent side the changes are. So the southbound side there's no change, so it's pretty much stays the same, and I am not expecting like vendor specific changes based on this. Yeah. From the current implementation. Yeah.
From the NorthBound manageability side, you're saying that is per platform based?
No. So on the NorthBound side, there's no platform specific thing, right? So it is based
Meaning
on this.
The form factor, whether it is a standalone DPU or smart switch, from that side of things.
Yeah.
Because the multi-ASIC architecture for switch, right? That is a little bit different from how we see DPUs here, right? DPUs have their own compute complex. This is a full SoC, so it has much more capabilities. So we, there is a chance to run whatever we need control plane in the DPU itself, right?
Yes. So I think we'll have to close on that design.
Yeah.
For sure. But yeah, today's discussion on today's protobuf, it's mainly on the NorthBound part.
Okay, the protobuf, yeah.
So I assume the next action item you'd like is any suggestions or comments into the PR as we move forward?
Yeah.
Okay.
Can I also ask a question about the data type? Because I see that protobuf field is encoded in the hash table the same way that we encode regular string fields. So there is the key called PB, and then value is the protobuf encoding. Will there be a difference if a different data type is used for protobuf, different than key value for that field? Like if we just use set instead of hset or something else?
In my opinion, we can change it. Why we use this kind of hash table, because we just want to keep the compatibility with the typical the interface compatibility with the typical SONiC table. Because in the underlayer we want to keep the same interface, and I did some experiment about that. If we just change the hash table to the packet list, the metadata is almost the same to the directed key value or hash table in the REDis. The metadata of REDis is almost the same, so we are not pay too many memory for that, but we can also keep the interface compatibility with the exactly system.
Yeah, I see. Thanks.
We can change some config in the REDis to make it you also use a package list hash table, not hash directly hash table.
Anyone else?
I wanted to just clarify. There was a comment shortly after my initial comment was, the ASIC, the AppDB doesn't have to be on the DPU, it'll be in the host, or let's say the switch. But that seemed like that assumption is okay. Well, it's solved because in a smart switch, the strong central processor holds the REDis database, and the DPUs just have syncDs. I mean, and that's according to this smart switch architecture in the DASH HLD. You can see that, and that's I'll share the link. But what do we do about the standalone DPU version? That stores everything, right? Does any DPU on the market have enough memory to hold this 41 gig just for the AppDB? I don't hear any yeses.
Yeah.
Oh no,
I think that's a
okay.
good
So
question.
no, this 41 GB is 4 DPU, right? So it's not really one DPU. So if you divide, yeah, sorry, 8 DPU. So if you divide it by 8, that is about 5 gig, something like that. So I think yeah.
Okay, that's good to articulate that. And that's why I'm thinking maybe a diagram showing how all this is laid out, where you have the central, you have an AppDB, you have ASIC DBs, you have two different configurations, right? Smart switch and standalone DPU for the appliance. And how these databases lay out for the different cases, I think would be nice to have.
I put that in the PR just a few minutes ago.
Thank you.
If it's possible, yeah.
Yeah,
I think that's going to be some separate design doc, not on this one. Yeah, so.
Well, but we need the context. We need the context, right? I mean, we're looking at, one optimization here without understanding the big picture. At least I'm not. I don't know if I'm alone in that, but we probably need a refresher or a high-level overview of how this fits in and what the objective is. There's a background conversation that we're not all privy to, and it would be nice to have a little background.
So one thing this table shows is unfortunately, it's kind of hidden behind the red box, is the per card usage, which is standalone DPU number that I'm sure vendors will like to know, right? It's like if you look at the table size, per card is what we care, or like vendors would care about, because that database size is on the DPU, right? Oh. Am I wrong about that? Like basically 5 gig, right? Assuming the REDis database would be 5 gig, right?
Yes.
And that's the one that vendors will care about because that has to sit on that DPU.
That would be just the AppDB portion if it were running the SONiC stack on the card. Right. Then there's the ASIC DB if it's not passed through, if it's stored. If we haven't changed the fundamental SONiC architecture, then it's going to be in the AppDB form as well.
Right. The thing about the ASIC DB is that it's vendor specific, right? So each vendor has to figure out what its size is.
No. ASIC DB isn't that stored in? Correct me if I'm wrong, but isn't that stored as a bunch of key value pairs or database entries, let's say, in REDis that represents the intended configuration of the abstract data plane, right? It's stored,
yes,
transformed and stored. So you might take one AppDB entry and it might turn into unknown number of ASIC DB entries when it's expanded and inflated, right? Translated. So That's why I think it's important to look at the big picture here. Let's just take one VNet entry. What is it? And with, some nominal, contents. What's the ASIC DB transformation of that? Because they're being stored simultaneously in REDis. They're just different translations of each other, right?
Okay, thanks for clarifying, because for me, ASIC DB was kind of the vendor stuff, but you're right, it's the copy of the thing in the REDis, yes.
And get sent down, right, on like an event level down to the vendors, and the vendor might store it internally however they want. If you have to be able to read it back, you have to store it in a form that can be transformed back. I know you raised the question many months ago. Do we have to be able to do a get on all these entries? Because that means when we have to store something it can be losslessly converted back into the read back version, right? Remember that conversation, Vincent, that you started? You were concerned about having to support a get operation on SONiC, on ASIC entries, because the cost of storing it in some form, some ephemeral form in the DPU might be high if you have to be able to set it, provide a readable value back equaling to the set value. Right, that's not for free. So there's a lot of implications here. Yeah, I think it'd be good just to have a reality check on because the scale's so vast.
And definitely a refresher on SONiC in general. Because again, we do not have access to DASH SONiC. And that's, that's fine. It is what it is, but.
Sorry, Vincent, you said we do have access to DASH SONiC, or?
No, we don't. That's what I'm saying.
So have you guys been to the SONiC repo and checked out the documentation on SONiC? Just curious, or if there's something I need to look for to give to you.
I personally haven't, and I probably should, because you're right. It's probably a lot of information is probably there.
Okay, all right. Yeah, I'll pop a link to the SONiC repo here. I'll put it in the chat window. There's a lot of documentation, and I can try and dig further to. You're basically just looking for a diagram of overall.
No, I think what the question Chris asked, I think the question was about getting what is stored where, how big, that sort of thing. I think it's the data that we're looking for, right?
Yeah. Do we have at least a prototype version of the DASH Orch agent that can turn AppDB into ASIC-DB entries? Does that exist somewhere?
Yes, that exists. So it's there in the SWSS repo.
Okay. Has anyone ever populated it with a full Dash config or even a scaled one that we can draw conclusions and extrapolate to a full Dash config? So, let's say at some nominal set of Dash entries and have that orchestrated and populate both the AppDB and the ASIC-DB, and then say, here's the memory footprint of this config. Has that ever been done? So we have a benchmark.
So I saw this proposal is mainly about the NorthBound API to change to protobuf, right? So those memory consumption, I think, is still under evaluation. So we do not have that.
Okay, but yeah, so this was kind of an early ask quite some time ago, by the community, various people saying at some point we need some kind of a footprint just so we stay out of trouble. And I think it would be a mistake to optimize one portion of this without understanding the whole thing. Again, I know I'm beating this to death, but if we already have a Dash Orch and we can apply a large scale configuration to the AppDB, we should very easily be able to say, here's the memory size for full hero test config or a full dash config or a baby hero, whatever, some scale number and say, okay, it's X gigabytes for this config. What do people think?
But you still, I mean, the memory footprint is still separate from the, the NorthBound API format, right? So I'm still having a, difficult to understand, why this, this might be related, but it's not tightly coupled, right? So you can choose whatever the NorthBound format, and then having a separate, memory consumption evaluations.
Well, it's kind of like you can't see the forest for the trees because this is a tree we're talking about. What's the forest look like? How many acres is it? That's the kind of thing I'm trying to get at. Do we actually have a grasp of the size of the memory footprint of a full dash config in Redis, regardless of how we
yeah,
it?
but how does it relate it to the NorthBound API that, whether we're using, the gRPC or, the protobuf as a format? How is it related? I'm still trying to understand, right? So I think the main proposal here is about using the protobuf for the NorthBound.
I understand, but there's the elephant in the room. The elephant is the size of the memory. My concern is we're going to get really clever about optimizing some NorthBound API that can't be applied to a database that's already larger than memory. It's the elephant in the room I'm talking about. It's not directly related, but it seems like avoiding. I feel like we're avoiding the elephant in the room.
But hold on, why should the same solution be applied to ASIC DB if Prince thought earlier that there might be other solutions, other trade-offs that we need to take, maybe not to store in ASIC DB at all? It may be not even applicable, but this solution is targeted for NorthBound DB.
Okay, well, I think I won't keep harping on this. I've expressed my concerns.
I mean, Chris, question for you. Are you saying that in the standalone appliance type model, if you were to push all config DB, app DB, and ASIC DB, you're trying to figure out what it's going to look like, what the limitations are? Or in the model that at least Prince and Guohan are saying is that the config DB and app DB is going to stay on the host, and then all the other stuff will stay on the DPU, right? I mean, where are you on in with respect to a question, right? With the forest and the tree analogy here, right? The separation is the tree is sitting on the NorthBound side, right? That's what Guohan's saying.
I think in the appliance, there is no host and there is no DPU. I mean, this is everything is basically DPU, right?
And if it depends on the architecture, how you're going to split this stuff, right? Typically, at the scales we are talking about here, fitting everything into the context of a DPU memory would be quite challenging in my view. So the model that at least Guohan and Prince and others are saying is it's going to be a split model wherein the stuff that's in config DB sits on the NorthBound, and what happens southbound is still up for debate in whatever fashion, and it's less of a challenge, or we will cross it when we get there. I think that's their thinking right now, from what I can read out of it. I'm actually okay with Guohan's comment on this topic. That's basically what I was trying to.
Yeah, exactly. I mean that's correct, right? So I think there's a appliance and there's a smart switch, right? So I think on the appliance, the memory in the appliance, I think also might be currently it's a little bit harder to store those into in current in some current skills, right? So but at least we put out our current evaluation of the memory consumption. If we want to install SONiC, what would be the memory consumption on those, right? So and they will continue discussing what options we have on that appliance cases. But I think on the smart switch cases, we already have a proposal on how we can store those things in the main switch CPUs.
Hey Guohan, on that spreadsheet, Why does it say 8 cards? Is that just an example, or is that specific to some vendor, or?
Oh, it's example. I think, you know, yeah, basically, I think there were some, you know, total we need roughly 1.6 terabyte, terabit. Yeah. So, and depending on the vendor, yeah. So.
Right. Okay.
That is the context of a smart switch, right?
Yeah.
It's a standalone IPUs, one card. So. Yeah, I think there are both mentioned here. A smart switch context of 8 cards and 1 card memory usage, which is, I guess, hidden.
Actually, though, I don't know if it's hidden if it says number of cards equals 8 and there's a total at the bottom.
The red square erases a number. The second to last row, it's like where it says 5 point something. That red is too thick that probably nobody looks at it.
Where?
It will be good to sort of
second to last,
make that
all
visible.
the way on the right.
What if there's a DPU that has 800 gig throughput, and so you only have 2 cards? I know of some.
I don't think we're there quite yet, but okay.
Yeah, from this slide, it will be good to have just one context of just 1 card, right? And then the question becomes that, okay, if your base assumption, the base premise is that host will store certain data and DPU will store certain data, then, you know, it will be a little bit confusing if it is a single standalone appliance use case. If we can clarify those two here in the slide or in some way, it will be useful. And also this memory usage is very important and very useful for us. If this can be added in the HLD somewhere, so we can all access it, it will be good.
Yeah, that's what I'm saying. I think, you know, we'll have a separate, you know, PR to do more, you know, thorough analysis on those, you know, performance and memory consumptions, right? So I think, you know, the many here is about the NorthBound APIs.
I have a question more related to the PR. The protobuf, so give us this saving from 60 to 40 gig. Is there any other type of encoding or way to represent this that will give us even more saving, like 20 gig, 10 gig?
Actually, I have some data in Excel. If we only store the key without any content, I mean without any attribute table, we will use about 20 gigabytes memory. So the 20 gigabytes I think is the minimum data the low limitation. I mean, but if we use some another experiment is about use the memory. We have this attribute value and we use some zip some gzip compress algorithm to compress the data. We will also got about 30 gigabytes. I remember that. Yeah, I have some data about that.
No, I think, Joe, I think there is a efficiency we have that, right? So, you know, you have this column usable data size and there's an entry size, right? From that point, we can calculate, you know, what is the efficiency of this, this way to encode, right? So then people can understand, okay, are we like 70% of efficiency in terms of this schema or, you know, whatever. Because the useful data is the data that, you know, you just need, right? So, you know, that there's not much you can improve. Then, you know, then you can calculate the efficiency. I think that addresses the question. Okay, so let's say, you know, if we achieve you know, 70% of efficiency or 80% of efficiency, then you know, then people knows, okay, if we want to do some other schemes, what could be the potential savings, right? So
I think the efficiency is not
Okay. Can I also ask about the key? Like, did we consider also compressing the key or using this encoding for the key? Because I see that in the proposal it says the key is
clear text.
using this.
Yeah. Here is the key only data. Actually, I try to compress the key to some binary format, but we don't have any gain about that. Only 100 bytes.
So I suggest, for that for this actually the stores efficiencies, who people interested, can work with offline, and can further explore other options, those things, right? So I think this is just preliminary data that we discuss. So there's certainly more work to do, right? So.
So Guohan, can I ask if you can post this on the alias, whatever your calculations here, or at least a preliminary sketch like you laid out, so we can kind of go back and do some homework and come back or sync up just to get a better of the numbers you're presenting here.
Yeah, I think Joe, maybe you can check and see if there's any internal data on this Excel sheet. If there's no, then we can do some work and get this Excel sheet published, right? So then people can analyze and check. That yeah, that is certainly doable.
Thanks. Yeah, thank you. Maybe Christina, you can figure out what's the mechanism to share this info.
Christina is taking a note.
Okay, thank you.
So it's 9:51. I didn't know if we had other PRs to cover today. I see a couple in the queue. Or do we want to keep going with this one? I see, let me look here. And of course, no one really said they were ready to cover them today. So let me just pull them up here. We have one support SCI attribute generations from annotations. We have GNMI design for DASH. Those are two newer ones. Those are probably too big to go in today, Marian, or I'm not sure who Gang Liu is, Prince.
No, I think I see Chris approved that, right? So
what? Oh, okay.
Yeah.
Oh, okay. All right, cool. Anything else on this one then for today? We have 8 minutes left, or any other Q&A you guys wanted to cover?
So maybe it was talked about, but this is AppDB from what I understand. Okay, that's running on the host. Did you guys ever talk about the ASIC DB size for, let's say, a 200 gig hero config? Okay, I don't know if we talked about that or not. If it's a non-number, because I believe the ASIC DB is it's on the DPU. It's what the SIND fetch from REDis, right? Is that correct?
The ASIC DB is still under investigation. Yeah.
Okay.
Okay, I guess I'll go around the room then. Bud, Reshma, Andy, Marian, guys got anything? BJ?
Nothing here.
No?
Nothing else. Not today.
Okay. Okay. Hanif, you've usually got something to say.
Not today. Thanks, Christina.
Not today. Okay. All right. All right.
I have one final thing to say. Happy Wednesday. Happy Wednesday.
Okay.
Yep.
All right. Then
That brought a smile.
I'm going to go ahead and stop the recording then. And do you prefer to be called Z or Pterosaur?
Huh?
We'll just call you Z. Go ahead.
Just call me Ze.
So okay, we're going to go ahead and stop the recording, and I'll make sure you
Okay.
get a copy and everything. Thank you for the contribution today. and
file.
I'll sync up
Thanks.
with you about the sheet.
Thanks, Christina.
Okay, thanks
Thank you
everybody.
for time. Bye.
No, thank
Thank
you.
you.
Bye-bye.
Bye bye.
Thank you.
Bye.